Well, thank you very much. My name is Doug. I'm a developer advocate with the Firebase team at Google. Fun fact about me, I picked up a bit of a cold on my way to London, so I'm using over-the-counter drugs to hold back a tidal wave of mucus that would terrorize even a Ghostbuster. So, a couple people know 80s movies. That's great. So, bear with me as I get through this. Many of you probably identify as front-end developers if you're doing Android. So most teams are split between front-end and back-end. Some of you might work across the full stack. If you do work across the full stack on your app, you probably know a bunch of different languages, which is great, but it can be difficult to juggle all of them as you move along the stack. And you probably know a bunch of runtimes as well, or operating systems. So you might have a backend running Node. You might have to run servers that use Linux, and of course Android itself, and then you have frameworks on top of that that you have to use. So if you're building an Android app, you probably know Jetpack. If you are building a backend with Node, you probably use Express, and of course there's the old but good Java 2 Enterprise Edition. So anyway, if you build across the stack, you're probably using a bunch of these. Now, the problem is if you also work across the stack, you probably have to manage your own backends, or maybe you have a team to do that. And the problem with managing your own backend is you have to configure it. So you have to tune it, you have to install the operating system, you have to manage it, you have to do upgrades, you have to patch it, make sure security is managed. There's a lot of work to do here. Typically, this falls under DevOps, but again, if you work across the stack, you have to manage this yourself. And then there's also the issue of scaling. So one server isn't probably going to cut it when you go to production, so you need to figure out how to scale that up. This is not trivial work. But for those of you who want to build an app on your own, you probably don't want to do any of this, but you want to have some sort of backend available. So Firebase comes in and provides a bunch of products to do that for you. I'm not going to go over the whole suite of products here. There's like 18 of them now. 2 of them are even missing. We just launched a couple more at the Firebase Summit Madrid. I'm going to talk mostly about the products here on the left. So the products on the left are what you can use to build better apps. So it provides the infrastructure for your app. The most common ones are Firebase Authentication to get users signed in and identified, give them a unique ID so that you can track them and store per user data. There's databases such as Cloud Firestore, which is a massively scalable NoSQL real-time database. If you're not familiar with that, get familiar with that because I enjoy working with that a lot. And for binary data, you can use cloud storage for that. The interesting thing about each one of these products is that when you're building an Android, iOS, or web app, you can invoke these APIs directly from your client. So you don't have to set up any servers or middleware or anything like that to talk to these products. You're just accessing them directly. But there's some things you really shouldn't be doing in your client. For example, payment processing. Probably don't want to trust the client in terms of handling payments. You probably want a secure backend for that. Also game logic. So if you have parts of your game that are sensitive to people manipulating it for cheating purposes, you probably want to put that on the back end. Data validation should be all done on the back end. You shouldn't trust the front end for that. And I've been saying over and over again, you shouldn't trust the front end. If you don't know, anyone can get a hold of your APK, download it, break it apart, reverse engineer it, get all the code, get all the configuration, all of the data in it. You should assume that your app has been compromised if you are security-minded. So that's why I'm recommending putting all this stuff on the back end and not in your app. Also, if you need to schedule periodic work, you probably shouldn't trust the client to do that, as devices are simply not on all the time. If you have batch data processing, obviously you don't want to handle that in the client. So all these things you should be doing on a backend. Now, if you're building your own app and you want to do these things on the backend, you probably have some preferences for this. So for example, you might want to minimize the time and effort for a solution. So if you identify as an Android developer and you want to branch out into doing backends, you probably don't want to learn a whole lot of new things. You probably want to get there as fast as possible. You probably want to minimize maintenance. So I don't know about you, but if you're building an app, the most fun part of building the app is the app itself. It's not the management of servers. If you do like managing servers, that's great. I don't know what you're doing at an Android conference. That's a very different thing. But I'd rather not do that. I'd rather make use of what I already know. So as an Android developer, Java, Kotlin are the things you probably already know. So if you want to do that, keep doing that. You probably don't want to learn a new language if it's at all possible. But as you do branch into backend stuff, you probably still have to learn something new. It's not going to be a seamless transition going from front end to back end. Now, the easiest thing, in my opinion, are backends that are called serverless. Now, serverless cloud computing, I will give you one pro tip. There are still servers. You can't get rid of servers in a serverless world. But when we say serverless, what we're referring to is the lack of management. So you don't have to worry about licensing software and operating systems. You don't have to install anything. There's no maintenance or support. All of this is completely removed. You only pay for what you use. So instead of standing up a server to run 24/7, even if you're not using it, you basically pay per invocation. So if you have a function to run, you pay for the invocation of that function, and that's it. There's no more payment other than per use. So if you're not using your backend at all, you pay zero. That's the promise of serverless computing. There's also automatic scaling. So it will serverless backend scale up as much as you need it to, up to some obvious limits, and down to zero again. So as users apply load to your app, the server will automatically scale up and automatically scale down, so you don't have to do anything. So what do you do if you're running serverless cloud computing? All you really do is write and deploy code. Now, the writing part is pretty obvious. The deploy part is a little bit more tricky, but it's still pretty straightforward. Now, the first option you should be aware of, and this is a very old option, I believe this is the very first Google Cloud product. It's called Google App Engine. With App Engine, this launched 10 years ago, so it's pretty old, but still relevant. You can run your backends in Python, Go, Java, JavaScript, or PHP. With this, you typically build a traditional REST API. So as you know, REST APIs are what you use to call from the client to the server or from server to server, your choice. But this is what you build. App Engine provides a number of services that you use along with it. So with App Engine, you have database options, you have memory caching, you have full text searching, you have a bunch of tools that you can use to build out the back end of your app. But you should be aware that App Engine does have limitations. Since it is 10 years old, it's just not built for modern architecture. So if you choose to use this, know that there are some limitations. And I'm not going to talk a whole lot more about this, because if I were choosing to build an app on a serverless backend, I would probably not choose App Engine, just because, in my opinion, there are better options out there. So the first thing I'd like to talk about is Cloud Functions. So with Cloud Functions, what you're doing is building functions as a service. So the unit of deployment with Cloud Functions is the function. That's it. You're writing and deploying units of code that are just functions. So you can build HTTP endpoints. So again, you can build REST APIs on top of this. Maybe the more interesting thing is product-specific event triggers. So if you're using Cloud Firestore as a database, what you can do is set up a trigger so that when any document is created, updated, or deleted, you can have some code run in response to that. Those are what we call background triggers, and they're tied to the product itself. So there are a bunch of products that generate triggers. I'll talk about those in a little bit. If you do want to use Cloud Functions, you can deploy them in JavaScript running in a Node.js environment, Go and Python. Java is actually in a private alpha right now. It's not publicly available. You can try to sign up for the private alpha. I don't know if they're taking new applicants, but this is hopefully coming sometime. Now, being that I'm on the Firebase team, I use a version of Cloud Functions called Cloud Functions for Firebase. Cloud Functions is a Google Cloud product, so the core Cloud Functions product is managed by Google Cloud, but Firebase adds tools and APIs on top of that that we think are very easy to use for mobile developers. So there's a CLI and SDKs that sit on top of Cloud Functions that make it super easy to use. So what you get is a CLI. You can write your functions in JavaScript or TypeScript, and they run in a Node.js environment. Now you're thinking, oh, JavaScript and TypeScript, I don't know about that. I don't want to learn a new language. And you might be right or justified in thinking this, right? Nobody really wants to learn a new language just to be able to write backend code. But I'm here to tell you today that TypeScript is a better JavaScript. I did web development way in the distant past when the web was still kind of a new thing. And when JavaScript came along, it was great. We can write JavaScript in browsers, and it works. But it's not a terribly robust language. At the time when I left web development, in my opinion, web browsers were kind of a mess in terms of supporting uniformly across all browsers and all versions of TypeScript, so I actually didn't like it. But when TypeScript came along, it made JavaScript a lot better to me. So what TypeScript adds to JavaScript, and I should say TypeScript is a strict superset of JavaScript. So all JavaScript programs are valid TypeScript programs. but TypeScript goes further and adds a sophisticated static typing system. So this is great because now you can actually catch bugs in code that are not related to duck typing that you normally have in JavaScript. You get generics, so now you can have lists and maps of things that you actually know what they are in the object. You have interfaces, so just like in Java, you can create an interface and it describes the shape of the object. You also have nullability guards, just like Kotlin. So if something could be null, if it's declared that it could be null or undefined, you simply cannot dereference it. TypeScript will not let you. So once you check for null or undefined, then you can use the object as you would normally. And there's community support for existing JavaScript modules. So if you have a JavaScript module that you really want to use, but it doesn't have TypeScript type bindings, the community has a bunch of type bindings that you can use. The project is called Definitely Typed, and so you can pull in those type bindings and use them on top of existing JavaScript modules and get all that wonderful TypeScript type safety. Now, for those of you who are doing Android, you probably know Java, right? This is a pretty standard Java class. It's a rectangle. It has 3 properties. You initialize them in the constructor, and then you have a public method that returns the area. So pretty straightforward. What does this look like in TypeScript? Almost line-for-line equivalent. So you can declare classes. You notice that types are after the variable, so you have a variable, and then the type is afterward, much like Kotlin. You have constructors where you can assign things. You have public methods. Basically, it's not hard to go from Java to TypeScript. Once you know Java, you're probably pretty well on your way to being able to generate TypeScript code. So if you want to use this object, you can do in Java, create a function, new up the rectangle, call some methods on it, build a string using string concatenation. The TypeScript, again, is very similar. There's a new keyword. You pass all the parameters just like you would normally. You'll notice that there's backtick strings, so you can build inline strings, which is super handy, just like Kotlin. Now, if you were to do all this in Kotlin, you can compress this down even further, right? So now you can define the rectangle without having to write code to initialize each one of the properties. The new keyword is gone. But when I look at these, I see that Kotlin is kind of a mix of Java and TypeScript. So to me, they're kind of all in the same family. So for me, going from Java and Kotlin to TypeScript is not really that much of a leap. But maybe the best part of TypeScript is there's an IDE available called VS Code. If you're not using VS Code to write your TypeScript, I feel bad for you because TypeScript because it has type safety, you can build IDEs on top of it. So this IDE, just like Android Studio, has files on the left, an outline, and then code in the main pane. The most interesting thing here is, as I'm typing snapshot.ref dot, and that dot says, TypeScript says, I know the methods on that, I know the properties on that, I will give you automatic completion, which is great. If you use JavaScript, you don't really get this. You get some guesses about some tokens that might pop up, but here, these are the actual options. So TypeScript is giving us a helping hand here. You'll also notice that if you choose one of those options, now you have the option to get some typed doc, which is a lot like Java doc. So the method, you can see it takes a parameter, it returns a promise that's parameterized by this write result. Everything you need to know about the method is here. If the authors of the library have written proper type doc, you will get all this in the IDE. So starting to feel a lot like home, right? As far as like Android Studio, jumping into TypeScript using VS Code is not a very long leap. So if you're thinking, okay, well, I'm willing to learn some TypeScript and I want to write some functions, how would you write a direct invocation function? So we're going to build a HTTP function. You can do this using Firebase APIs. So on the back end, what you get is a function definition that basically emulates Express.js. So if you're a Node and a JavaScript developer, you probably already know Express. This is the HTTP framework. There's only 2 parts of this you need to know to work with Cloud Functions, and that's request and response. And they do the things that normal HTTP request and response objects do, so it's not really hard to learn. You can provide your own full Express.js app if you want. You can build that entire app complete with middleware and routes with wildcards. You can do all of that and install that as your function. So if you want to write a simple function, this is what it looks like. So we're using the TypeScript SDK. So the first thing we'll do is import the Firebase Functions SDK. This gives us the ability to build or declare functions. So I'll read this from left to right. We're declaring a function called echo. We're using the Functions SDK to declare an HTTPS trigger. And when a request comes in, we're going to get a request and a response object. Those are those Express.js request and response. We can pull things out of the query string and then echo that back out to the client. So pretty straightforward. This is not a terribly useful function, but you can kind of see how it goes. Now, this is a complete function. To deploy it, all you have to do is use the Firebase CLI and type Firebase deploy, and that's it. It will just pick up all of the functions. Right now, there's just one, and deploy them all. When it's done, you'll get a URL. So the URL is based on the region where you've deployed it, so that's US Central 1, your project ID is in there, and then the name of the function is the trailing part of the path. So if you curl on that, I imagine most of you know how to make HTTP requests. If you curl it, it will invoke the function, and that's all there is to it. So really easy to get started. Now, while this is very easy, it's actually, Firebase goes even further and makes it super, super easy to invoke functions from your app. So Firebase introduces something called a callable function, and it's a wrapper around HTTP functions. So we will use a provided SDK for Android, iOS, and the web, and then there's an SDK for the function side as well that you declare in JavaScript or TypeScript. These SDKs will do a bunch of work for you automatically. So all of the details of HTTP are handled. You don't have to know any of it. You don't even have to know the URL. The SDKs basically communicate with each other directly. On the client, it will send automatically the Firebase Authentication ID token. So if someone's logged into your app, that token will become available. It will also send the device ID token if you're using Firebase Cloud Messaging and you want to target the device for cloud messaging. It will also serialize an input object as JSON. So if you give it a POJO, a regular old, plain old Java object, it will use reflection, find all the getters in there, convert those into properties, and serialize that as JSON. So right now, we're doing very little work to actually invoke this function. It's kind of like an RPC call. You're basically saying, go run that function, pass it an object, and then on the server, it will validate the auth token to make sure that the user isn't faking their identity, and it will also deserialize that input object from JSON. So you'll just be handed a JavaScript object with all the properties that were matched on the input object. Okay, so how do we write a callable? Again, using the Cloud Functions, or the Firebase Functions SDK, we can declare a new function called a sum. And using the Functions SDK, we'll declare an HTTP function. And on call, not on request, but on call, this is a callable function, we'll get that data, that input object that was serialized from the client, and we can do something useful like add two properties together. So I don't know, not very useful, but you can see how it works. Then on the Android and Kotlin side, if you want to invoke this function called sum, all you have to do is declare a map that has all of the properties. So I'm not using a POJO here, I'm just using a map, a Kotlin map. Properties A and B get values 4 and 5. Then I'll use the Firebase Functions SDK on the client side, get the singleton instance, get HTTPS callable. All I have to do is know the name of the function and call it with the argument. That's it. If I want to know the result, all I need to do is add a completion listener. The completion listener will get the result of the callable as a map object. I can reach into it. It's map as well, and I can see the sum. So there's not a whole lot to it. If you want to check for failures, which you should, you can do that as well. So this is pretty straightforward stuff. This makes it really, really easy to set up front-end, back-end communication. Again, here, all the details of HTTP are completely hidden. You're just basically setting up functions to call and then calling them on the client. Now, I mentioned before that there are event triggers as well. So HTTP functions are one thing, product triggers are another thing. We call these background functions sometimes. When you build a background function, there's a few things you indicate. You have to say the cloud or Firebase product that you're interested in listening to. So this is called the event provider. The type of change you want to listen to. So in the cloud Firestore situation, you can listen to document creation, update, or delete, or all three. You indicate a pattern to match for that change. So if you're interested in only documents in a certain collection, you can specify that. Once you've written your function, they will trigger asynchronously after the change occurs. They aren't synchronous. They don't sit in the execution path. They're after execution. So these triggers happen sometime later, usually very fast. Now you might be wondering, well, what kind of products can I listen to? Here's 8. There's actually more than this. There are a bunch of different types of triggers. The most interesting ones to me are Cloud Firestore, like I said. Firebase Authentication, when someone signs into your app for the first time, you can call back on that. Analytics is actually very popular, so that if you're using analytics and the user triggers what's called a conversion event, meaning a high-value event, you can trigger some functions on that as well. Cloud storage, when a file changes in your cloud storage bucket, you can write some code as well. Again, this isn't the whole list. This is just what happens to fit on this slide. Now, Cloud Functions is event-driven, as I mentioned before. So these event providers, they're going to, as the users interact with these products, they're going to emit events, and they go into Cloud Functions. And Cloud Functions, you can think of it as a container for all of these events. This container is going to figure out which functions need to be executed and go ahead and kick them off. So it's really not very complicated. You just have to understand that there are event providers, they emit events, then that triggers functions. So if I wanted to write a function that uses Cloud Firestore, again, I'm going to import the Firebase Functions SDK, declare a new function called emojify. So I'll read this left to right. Using the Functions SDK, I'm interested in Firestore changes when a document that matches this pattern, and that pattern is saying in the messages collection using some wildcarded ID, so any document with an ID, when that document is created, I'm going to get a snapshot object, and then I can handle this snapshot object by checking to make sure it has data, which it will for an onCreate. I can start pulling fields out of that document, so that document will just assume that it has a field called message. I'm using TypeScript to cast it as a string. This is great because I don't have to assume. I can just, well, actually, I'm just assuming. I should check to make sure it's a string, but I'm assuming. And then I can start calling methods on that string. Here, I'm looking for the string cat, and I'm replacing it with a cat emoji. I'm really good at writing useless functions. You should never have to write a function like this. But it's a fun example, right? Because we all love cats. Actually, it's kind of funny, and I'm going to write that back into the document. Now, it's funny here because obviously this is going to work for the word cat, but it's also going to pick up catatonic, catapult, catharsis. So I don't recommend that you do this. You should probably put like word boundaries in there. But anyway, off to not showing, oh, one more thing. You'll notice that there's these keywords async and await in here. This is how in JavaScript you do asynchronous programming. So if you know Java and you know Kotlin, actually, if you know Kotlin, you know that there's this thing called coroutines, and coroutines gives you a way to express how to execute sequences of asynchronous work in a way that does not generate callback hell. JavaScript has the same thing. In fact, JavaScript kind of invented it. It was the original async program. Well, I'd say the original, the most popular language that introduced it. So you'll notice that async keyword up there on snapshot. This is similar to defining a suspend function in Kotlin. So as you know, a suspend function always turns right away and returns a deferrable. In this case, this function always returns right away and returns a promise that indicates when the work is done. Then if I'm going to call a method that itself returns another promise, as does update. Update is an asynchronous method. I can await it. That's going to return the result of that update. In this case, I'm not interested in it. But I'm basically making the top-level promise returned by the top-level function. It's going to wait for all of the asynchronous work. That's how Cloud Functions knows it's time to shut down your function and clean everything up. So if you know Kotlin, again, should be pretty straightforward to get involved with TypeScript and JavaScript. So if you want to use Cloud Functions for Firebase, there's a few things you have to know, sort of in summary. You will have to know something about Node.js. Everything I showed you so far, you actually don't have to know anything about Node.js for simple functions, but you should know a little something. You have to know something about NPM. That's how you get packages installed, similar to Maven. So you know, in your Android build.gradle, you put your implementation dependencies in there. NPM works the same way. You just NPM install the thing you want to use. You're going to have to know some JavaScript or TypeScript if you're using the Firebase SDKs, which is, again, I think not the worst thing to have to learn. You're going to have to learn something about asynchronous programming with promises. This is where beginners always get messed up. If I had, actually, I'm on Stack Overflow a lot. I'm going to say that I have thousands of points just answering people's questions on async await, because it's an easy thing to get wrong, but it's easy to learn as well once you get the hang of it. If you're building HTTPS functions, you're going to have to learn something about Express.js, those request and response object, and a few CLI commands. So you're going to have to learn how to basically type Firebase deploy. Pretty simple. If you want to learn more about Cloud Functions, there's a bunch of links here. The documentation is quite good. The video tutorials, I will say, if you have not enjoyed looking at me and listening to me so far, don't do the video tutorials, because it's all me just talking about Cloud Functions. So be prepared for that. You're just going to see a lot of me if you do the video tutorials. And I have in gists, I have some samples of things that I think are pretty clever use of Cloud Functions, so check that out if you're interested in some neat samples. Okay, so that's Cloud Functions. You can build out fairly robust back-end code with Cloud Functions. But there's one more option you should be aware of. It's called Cloud Run. With Cloud Run, it's also serverless. But the big difference between Cloud Run and Cloud Functions is that you're going to create a Docker image. So if you know Docker, you'll be right at home here. If you don't know Docker, there's kind of a learning curve to get acquainted with how to build an image to deploy. With Cloud Run, you're basically implementing HTTP endpoints, so your Docker image is obliged to run an HTTP server, listen on port 8080, and start handling requests from there. But the good news is you can do it in pretty much any language and runtime you want. If there is a Docker image for some combination of runtime, web server, and language, you can use that image. There are really no rules about what you can and can't use. It's just what you can express with Docker. There are no native product triggers, so those event-based triggers you saw with Cloud Functions, these do not exist with Cloud Run. If you want to use triggers with Cloud Run, you would have to bridge from Cloud Functions. You'd have to write a function to get that event, then pass it along to Cloud Run, which is doable. It's extra work. Cloud Run is currently in beta, but a lot of people are using it, so we think it's production ready. We're just trying to figure out all of the little quirks and kinks, trying to get all the little details worked out. Now, you might be wondering, as an Android developer, can I build a backend with Kotlin? The great answer is yes, of course, you can build with Kotlin. All you need is a JVM image and compile your code with Kotlin and deploy it to Cloud Run. So I'll show you how to do that. You'll need a build.gradle for your Kotlin backend. As an Android developer, you probably already know how to work with build.gradle, right? It's going to be a little bit different. You're going to need a Kotlin plugin. You'll need an application plugin. The application plugin lets you run standalone command line apps, basically. Pull in implementation dependencies just like you would normally. In this case, I'm using a web server called Ktor. Ktor is a Kotlin native web server. So if you know Kotlin and you're familiar with Kotlin Fluent APIs, this is very handy. You can define your main class name. This is the main class that gets invoked when the application starts. And here's how you build a jar. You need one big fat jar. What we're going to do is wrap up all of the compile dependencies, tell it what the main class name is. That becomes a jar. We're going to copy that jar into the image. Next, you'll need a Docker file. To build a backend that runs Java, we're going to do a two-stage build. So Docker lets you build images that turn around and generate build artifacts that can be used in a second image. So here, we're doing a builder image. So when you say from Gradle 562 JDK 8, that's a Gradle image. We're going to use it to make a builder image. We're going to copy our build.gradle in there. We're going to copy all of our source code in there. We're going to run a Gradle clean build. So this is just going to run inside a Docker image, a clean build. Oh, by the way, if you have other jars and stuff in there, you'll need to copy those as well. But in my simple app, it's just a source directory. Now we need stage 2 of the build. So in stage 2, this is what's actually going to deploy to Cloud Run. We're going to need a JVM image, so we're going to use OpenJDK for that. This is a kind of a stripped down version of the JDK, very minimal. We're going to copy that file from the builder image, so the app.jar that was created by the first image, and we're going to copy it into the image in a file called app.jar. So now we have Java. We have our app.jar. Since we already have Java, all we need to do is run the command line and say, hey, Java, run that jar file. It will start up a web server, assuming you've coded it up properly, and that's how you listen, basically, it will be on port 8080. This is kind of a minimal Docker file. So without knowing anything about Docker files, you can kind of copy things that are there, make them work for you. Now you might be wondering, what's the code? What do I code up in that jar file so that I can run an HTTP server? So you're going to have a main function, just like normal Java programs or Kotlin programs. You're going to pull the port number to listen on. It's always going to be 8080, but you should use an environment variable for that. Cloud Run sets that up for you. You're going to run the Ktor embedded server, and what I'm saying here is it's using Netty for an engine. So Netty is a Java-based network server. That's what Ktor is built on top of. We'll pass it the port to use, and here's that Kotlin Fluent API for defining your routes. So here we have a routing, and there's one route in there called greet. So whenever a GET request comes in on greet, we can run some code. Now, I don't advocate putting all of your routes all in one giant file. You can break these out, of course. But this is kind of your simple hello world program. All right, so assuming we have this code, how do you build and deploy it? It's a little bit more difficult than Cloud Functions. You need to know two pieces of data, your project ID and your service ID. You're going to build a tag from that. So think of this like a shell script. So gcr.io, that's Google Cloud Run.io. This is a repository for your built images. You're going to deploy to that. So gcloud build submit with a tag is basically going to go off and build that Docker image for you. So it's going to take a Docker file. It's going to run all of the commands in the Docker file, build that image, and deploy it to Cloud Run. Now, it's not fully deployed. It's just in this repository. To actually deploy it from the repository into production, you'll run gcloud beta run deploy, give it the image, give it the platform. Platform manages this basically saying, I want Cloud Run to do all of the management for me. That's it. So you have to know these two commands. And once you have them, you're basically just going to put them in a shell script and run them over and over again. So with Cloud Run, what exactly do you want to run? You can decide for yourself. You need to make some decisions. Which HTTP server are you going to run? You have basically the world of options to you from all HTTP servers. You can run a servlet container if you want. So if you're into Tomcat, you can run a Tomcat server. You can decide what framework you want. So Spring, Java Server Faces, GWT, Struts, and Play. You've got a lot of frameworks to choose from, or just Ktor if you want to do Kotlin. What do you have to know to use Cloud Run? Well, some programming language, some runtime, and some HTTP server of your choice. That's what you have to know. So you can use whatever you know. You're going to have to know how to build or modify a Docker file to create the container. So what I usually recommend is go find an example of a Docker file that does what you want, copy it, and use it as is, or make tweaks to it as you see fit. Cloud Run, I believe, has a bunch of examples on their homepage. You're going to have to know how to integrate your backend code with the container. So there's this contract between your code and the container, basically listening on port 8080 for HTTP connections. That's pretty straightforward. You're going to have to know a few gcloud CLI commands. Now, gcloud is Google Cloud CLI. It is a big, fat CLI. There are like hundreds of commands in there. It's much more complicated than the Firebase CLI. The good news is you only really have to know a couple of them to get going. Nice to know is how you can test your container locally. So those two gcloud commands that I use to build and deploy my container, those take about 3 to 4 minutes to run. That's not exactly great for local development. What you can do is test your web server locally and use curl to hit it, so test your endpoints like that. That's a good skill to learn to know how to do. I use IntelliJ for that, so I just use IntelliJ's run command to start up my server, and then I do all my local testing before I deploy. So you might be wondering, so which one should I use? Should I use Cloud Functions or Cloud Run? I'll break it down. I think Cloud Functions is a little more simple than Cloud Run. With Cloud Functions, you need to choose a runtime, and that's it. With Cloud Run, you need to choose an HTTP server, a language. You have more choices, but it's a little more difficult to get started. With Cloud Run, you have to write a Docker file. You don't write one for Cloud Functions. That is all hidden. There's Docker behind the scenes. You just don't have to know anything about it. Then you write code. With Cloud Run, then you have to go further and build a container with the code added, and then you go through your deployment. So you can see with Cloud Functions, there's fewer steps. It's generally easier to get started. With Cloud Run, you have more options, you have more flexibility, but it's also harder to get started. They also have different limitations. So with Cloud Functions, you are limited to a set of languages and runtimes that are supported by Cloud Functions. So I listed them earlier. With Cloud Run, you can do whatever you want. With Cloud Functions, it's easier to set up and deploy. Firebase has callable functions, which makes it super easy to create HTTP endpoints. Cloud Run is a little more difficult to set up and deploy, but that is, that's to be expected. More flexibility means more complexity. With Cloud Functions, you can only deploy code to Cloud Functions. So when you start using Cloud Functions, you are effectively locked in. Now, you can reuse that code elsewhere, but the infrastructure itself, only Google Cloud Functions can run Cloud Functions code. With Cloud Run, once you build that Docker container, you can, in theory, run it on any cloud provider. So you can pick it up and run it on other clouds that have a similar contract as Cloud Run. With Cloud Functions, you can trigger Firebase and Cloud Product events. Now this, I really like this a lot. There's a lot of flexibility in here. Cloud Run simply will not do that. You would have to write some proxy code to do that. So all things considered, I prefer Cloud Functions. I work a lot with Cloud Functions, but Cloud Run can be used if you want to reuse, say, all of your Kotlin knowledge, or reuse all of the Java libraries, the JVM libraries that you're using. So there are some trade-offs. Now, I mentioned that serverless products scale up and down with load, and I'll illustrate that briefly. So if you're using Cloud Run or Cloud Functions, when users apply load to these products, you will see a server instance allocated. Actually, you don't see it. It happens behind the scenes. But as load increases, the number of server instances increases. This is automatic. You don't have to do anything for this. As users pile onto your app, you will get more and more and more server instances. For Cloud Functions, I happen to know that there is a maximum of 1,000 concurrent server instances that can handle all of these incoming events. That's a lot. If you ever exceed that, call us. We'd like to know what your use case is. But there are obvious limits. So when the traffic on your application dies down, the server instances die down as well. And like I said, if you are running 0 functions or 0 Cloud Run instances, you pay 0. That's all there is to it. How much time do we have? Like 1 minute. Okay, I had a very simple demo. I guess I won't do it. It's basically a simple Kotlin Android app that basically uses Kotlin serialization to send an object over to Cloud Run, also running Kotlin. We use Kotlin serialization to deserialize that object, make changes to it, and send it back to the client. In my opinion, if you were to write Cloud Function or Cloud Run code, using Kotlin serialization is a great way to manage that communication between front end and back end. And you can reuse all of those object definitions without having to copy all of that across the front end and back end boundaries. So that's all I have. Thank you very much. So I guess we have time for questions.
Yeah, thank you very much, Doug. Does anyone have questions at all? Yeah.
Just wondering, are both the Cloud Run and the what's the other thing called Firebase?
Cloud Functions?
Yeah, Cloud Functions. Do both of them have like Kubernetes running under the hood?
So you can actually deploy Cloud Run to Kubernetes. So Cloud Run in a managed service doesn't really expose any of that, but you can take Cloud Run and deploy it on Kubernetes so you can have more control over your cluster. So you have more advanced options with Cloud Run than you do with Cloud Functions.
All right, thanks.
You mentioned the periodic jobs to be executed. Can you use that with Cloud Functions?
Yes.
And how will it make the load? For example, I don't know, I need to run every hour or something, and I need to query my server database and do some computation and stuff like that.
So Firebase adds, with its SDK, a way of scheduling functions using cron, using a cron-like syntax. So if you know those 5 numbers, and most of them are stars, you can say run this function every minute. That's up as often as every minute, but you can also go every day, every week, every month, so on. So all you do is use those 5 numbers, or you can say, you can use English, and you can say, run my function every 1 minute. You just type the text every 1 minute, and it will do that as well. So yeah, that's very possible. It's very doable. What it's doing behind the scenes is it's actually using Google Cloud Scheduler to send a pub/sub message to a pub/sub function. All of those details are completely hidden from you. You don't worry about that. All you do is specify the cron frequency.
I can just have a small follow-up. Basically, let's say you want to run this for all the users that did some sort of an action in your app, but you don't want to run for all the users at the same time because you will create a big load for your server, I guess. So how will it do the split, or is there a way to manage the load?
There's no real easy way to manage that. You would probably want to create a function that runs more frequently, like every minute, and then batch your users. So query, batch 10, do 10, then wait a minute, and so on. So you can shard your database users, basically.
Thanks.
Any other questions? Back there.
Hiya, thanks for the talk. We use AWS Fargate, and I can see that Cloud Run's probably a bit of a competitor for that. But obviously with Fargate, the container's continuously running, whereas it seems like with Cloud Run, I guess the container runs up and then runs back down, so you pay for when it's running. I'm just wondering, what's the startup time like on that? Do you know?
Yeah, so what you're referring to is called the cold start time for a server instance. Both Cloud Functions and Cloud Run have cold start times. That's unavoidable in all serverless frameworks. Being able to scale down to 0 clearly means there's a cost of having that first and subsequent images starting up. With Cloud Run, the cold start time is mitigated by the ability to handle multiple incoming connections all at once. So if you have one server instance running, you can handle up to 80 concurrent requests on that image, whereas with Cloud Functions, each server instance can only handle one at a time. So the cold start time, because of that behavior, the cold start time for Cloud Functions is a little bit worse. Now, if you're trying to figure out what your cold start time is, that's something that you'll have to do from experimentation, because basically you're paying for the cost of like Node.js to start up. You're paying for the cost to parse all that JavaScript. TypeScript compiles down to JavaScript. You're going to have to load all those libraries, and then you finally get to the part where you handle that event. So it depends. It also depends on what type of function it is. So Firestore triggers happen a lot more slowly than HTTP triggers for whatever reason. I don't fully understand it. So with Cloud Functions, basically, you're going to inherit a slightly worse cold start time. With Cloud Run, you're not going to see that as much, but it's still there for some of the requests. I hope that answered your question.
Yeah, that's great.
Okay.
Thanks for that.
Hi. Yeah, so you've shown the client executing a Cloud Function. Can a Cloud Function execute client code?
No. The easiest way to get backend code to call something on the client is to use Firebase Cloud Messaging. Send it a packet of data in that message, ship it off to the client, and the client can determine what to do with the data that's in the message. So that's typically how that would be implemented.
Any other questions?
These are good questions too. Thank you.
Hi, thanks for the talk. How do you test your Cloud Functions? Like automated tests or something like this? Can you do that?
Yeah, so Cloud Functions, well, I'll speak about Firebase, not about Google Cloud version functions. So Firebase in its CLI offers a way to emulate functions locally. There's also a unit test library that lets you unit test your functions. So you'll have to know, I think, Sinon and like, I can't remember all the names of the JavaScript frameworks that give you a unit testing framework. There's also a Cloud Functions shell at the Firebase CLI, so you can fire up the shell and just pass it raw JavaScript data to the function and see if it works the way you want. So you have a number of options. I definitely suggest investing some time to do that. Because deploying a function takes about anywhere from 30 seconds to a minute, and cycling through that can be rather painful, but yeah, local testing is super easy.
Any other questions at all?
If you're using Firebase Auth in your Android app, is there any way to use that auth in a Kotlin Ktor type scenario?
Yeah, so if you want to know who was invoking a function, usually what you do is get a hold of that ID token. The client has to pass that ID token, usually in an HTTP header. So you might see code that says authorization bearer and then the ID token. There's a Firebase admin SDK that you can use to validate that token, get the UID from that, get all their custom claims so you can know who is invoking that function and that they are who they said they are. So that's how you do the back and forth communication there.
Any other questions? Final couple questions? Sure.
Great.
Well, if that's
Thank you.
everything, thank you, Doug, and just give him a round of applause one more time.